Now let's move on from here and let's try to move from atoms to the complex systems. Let's try to move from atoms to life. So we will be trying to understand it from quantum point of view. We'll try to understand the world from quantum point of view. So here we'll be talking about from atoms to life. We'll be trying to understand, try to go deeper into this argument. So let's begin with the same argument. Everything you are, I mean, every thought that you have, every heartbeat that we experience, every memory that is built from atoms that do not behave the way common sense believes, the common sense expects, the common intuition works. It doesn't happen that way. Now, if atoms behaved like tiny solid balls, they behave like very much strict, very much predictable, very much mechanical. Life as we know it would not exist. It would not have the existence that it possesses. It would not have the mechanism that it goes with. It would not have the light that it possesses. So we have to move from the visible world of cells and genes. We have to move down into the invisible rules that govern the smallest scale of these important domains of life. Now, because before we understand genes deeply, we must understand the stage on which they are built, the stage on which they exist. And that stage, to my understanding, to the understanding of the world, is quantum mechanical. That stage is quantum. And the illusions that we have from classical point of view, if we incorporate the classical view, we come up with the illusions. Let's try to understand. Let's begin with what most people imagine. The most of the people. What they imagine is that an atom is often pictured as a miniature solar system. You have sun and then you have the planets. And the electrons are assumed to be orbiting around the nucleus of an atom. There is a solid nucleus at the center of an atom. And electrons, they are orbiting like planets. And this picture is very neat. This picture is very clean. This picture is very much predictable. You can predict every action of the electron with respect to this solid nucleus. But this picture is incomplete because at atomic scales, at the lengths of atomic size, electrons do not move in simple circles. They do not move in orbits. Their exact position cannot be precisely fixed. Their behavior is described by the so-called probability, the quantum mechanical probability, not by the certainty. Now imagine trying to photograph, say for example, we want to photograph something in total darkness, say an electron, using a flash of light, so powerful that it pushes the electron, and we can replace it by a bird. It pushes the bird. So the act of observing the changes what you observe. You have acted with a very strong flash of light on the bird. The bird is pushing. So the reality of the bird is already taken on. And this is how physics treats things at small scales. At small scales, certainty dissolves into the probabilities. Because the act of measurement is disturbing your system. The act of measurement is collapsing an infinite number of probabilities that could exist for that miniature particle-like electrons. So we have quantum behavior at the atomic scale. And these genes are seated on these atoms. So the base of these genes is living with these atoms. Now, what does quantum behavior actually mean here? How we can translate the mathematical reality into some simple phrases. What it means three essential things, three important parameters, the three important physical quantities that can be measured. Energy, the number one, I should say, the energy comes in discrete packets. It comes in discrete levels. Particles behave like waves. They do have particle nature, but they can have a nature of waves outcome. And there are outcomes, and the outcomes are probabilistic. Now let's take them one by one, because our seat of connection is here, genes, and we have tried to understand what genes are. And we are trying to boil down them to the quantum mechanical description. The very first thing that I talked about is the discrete energy. And what does discrete energy mean here is that electron cannot possess just any energy value. It is possible for the Earth moving around the sun. It has any value of energy. It has continuity in its energy it can occupy. But electron can only occupy specific allowed levels. It cannot occupy all the energies. Like steps on a staircase. If you have a symmetrical staircase, the steps can be The steps can be treated as the quantized energies. And you cannot treat the energy of electrons as a ramp, as a smooth ramp. And if we jump to the biological molecules from here, in biological molecules, this matters because you have chemical reactions taking place in the biological molecules, and chemical reactions certainly depend on the motion of electrons. They depend on motion of electrons. That should be kept in mind. So if the motion, if these reactions depend on the motion of the electrons, they depend on these discrete energy levels. Now think here, if energy was continuous, or if energy were continuous, the reaction control would not collapse. It would collapse. There will be no control of the reactions if there is no staircase of energy packets going on at the atomic level. So here we can say that life depends on quantized energy transition. Because if there is continuity in the energy at the atomic scale, then you cannot have the control that you can see in building these complex structures. Now going to the next thing, what's called probability. Because in quantum mechanics, we deal with probabilities. We are nowhere close to the certainties. And if I repeat the argument, in classical thinking, if we know the starting position, and the speed of the ball, suppose you have a ball, you know its initial conditions, you can accurately predict where this ball will be in the future at any interval of time. You can predict with what force it will hit the ground, with what momentum it will hit the ground. Now, at atomic scales, this breaks down. This is not the reality at the atomic scale, and atomic scale is the basis of these genes. What we use here is wave function. What we use here is the basic postulates of quantum mechanics, the basic equation, Schrodinger's equation. And what it gives us probabilities. It is not giving us the future of the ball that I was talking about, of whom we know the initial conditions. There's no guarantee, no guarantees. Now, inside the DNA, electrons are shared. You have the DNA molecule, and electrons are shared between the atoms. There's mutual sharing of electrons. And the stability of the genetic bonds, the stability that we perceive in those molecules, the stability depends on this probability distribution of electrons. So this is how it makes quantum mechanics itself so fundamental, that even the stability of your genetic material, it's stable. It rests on these quantum mechanical probabilistic laws, these probabilistic outcomes, these probabilistic distributions. And there is another important argument, and what we call as wave-particle duality. You have the wave-particle duality. So you have an equation for that, lambda equals h by mv. Now, we would like to reach one of the most misunderstood ideas, duality. And this was predicted by Louis de Broglie. And what we have the wave-particle duality. A particle can have dual nature. So here we can say that the electrons who are taking part in these genes, is an electron a particle? The answer to this question is maybe yes. Electron is a particle. Now, is it a wave? The answer may be yes. It is a wave. For particle nature of electron, we have photoelectric effect. And for wave nature of electron, we have Davison-Germer experiments. They are confirming. Now, is it a contradiction? See, if we think in classical sense, there is a contradiction. It means the behavior depends on how this particle interacts. This is what the dual nature basically means. And we can choose a simple example, and an example of, say the example of the ripples. I mean, an analogy of ripples. So if the very argument that if you have a pebble of stone, you drop it in the water, and what you see is, you see the ripples form. And these ripples, they seem to be moving. They're not actually moving. Now imagine that ripple can sometimes strike like a tiny bullet. You have the ripple, but at times these ripples can behave like bullets. And this is happening. This is what's happening at atomic scales. Matter splits like wave of possibilities. You have a wave of possibilities. But when it interacts, it behaves maybe like a localized particle. And for that, we have that photoelectric effect confirming the particle nature of light. And inside the biological system, inside the biological molecules, electrons are not tiny beds that are stuck in place. These electrons are continuously forming ripples. They exist as a spread out of probabilities. They exist as the probability clouds that are spreading, coming from all directions, very confusing, looking very chaotic. But this chaos is giving the stability of these systems. And these clouds that you have, these clouds are mathematically deterministic. So bond length, molecular shape, these are some of the fundamental characters. Reaction likelihood among these molecules and molecular shapes, they determine the biological function. They determine the act of a biological system. So wave behavior influences. It influences life. It influences biological life directly. It has a direct impact on biological life. Coming back to that tunneling aspect. Tunneling, crossing the impossibles. Crossing the walls that are impossible. So here we have even more astonishing example that contradicts the biological argument, that contradicts the classical argument. What in classical physics we have, if a ball does not have enough energy to cross the wall, it will be stopped by the wall. The ball will never cross the wall. But that's not the reality that's happening at the quantum mechanical level, at the level of atoms and molecules. And what we have here, we have quantum physics. In quantum physics, there is a small probability that the ball may appear on the other side of the wall. Provided your ball is has a dimension of the order of atomic scales. And this is what is called as, we call it quantum tunneling. We call it quantum tunneling. Quantum mechanical tunneling. And let's connect it. Let's assume DNA. Let's assume this process in DNA. Now, within DNA, what we have hydrogen bonds. Okay, and hydrogen bonds, they make the base pairs. They make the base pairs together. And protons in these bonds, the protons as hydrogen atoms, in these bonds can sometimes tunnel. They can cross the barriers which are impossible for them to cross. They can cross the walls which are impossible for them to cross. When that happens, base pairing can temporarily shift from one state to another state. And this shifting of the base pair, and this shifting of the base pair can basically contribute to the mutations. So a process that classical physics would forbid. The classical physics will have no answer for. The classical physics will fail to explain, actually participates in the dynamics of genes is what? Is this quantum mechanical tunneling. Now the question arises, why life cannot escape quantum laws? It has to follow these quantum mechanical laws to have that complexity, to have that stability, to have those mutations in the genes. And you might ask that biology is raw and messy. Is not quantum behavior too fragile? Isn't it very much fragile for life? Because the basic mathematical arguments, the experimental outcomes that we have, they need those basic things. It's a very reasonable question. We are trying to build a quantum computer, and for that, we need very lowest temperature. But here is the key insight, basically. The key insight is that life does not escape, basically. It doesn't move away from quantum rules. It does not escape from quantum mechanics. Life operates on the top of the laws of quantum mechanics. What I mean is that every chemical bond, the bond between the atoms, it's quantum mechanical in nature. It's the result of the rules that are set by quantum mechanics. Every electron transfer in metabolism is quantum. It's quantum mechanical. That's why you cannot escape the death. Every photon absorbed in the vision, the photon that's hitting my retina right now, is hitting my retina quantum mechanically. In the act of smelling, you have certain molecules, they depend on quantum mechanical vibrational interactions in your nostrils. So biological science is not separate from physics. I think it should be the part of the physics now. The time has come when biology should be taught in the framework of physics, and it should be organized in the framework of physics. It should be advanced in the framework of physics. So, even if we think about from atoms to molecules to genes, you are setting your stage of genes from these basic elements. And let's build upwards. So you are building these genes from atoms to molecules. And atoms, which are the basic bones, they follow the quantum mechanical rules. Atoms form molecules. They form molecules through quantum mechanical bonding. They are not forming these molecules because of some rigid walls between them. Molecules form DNA, and through chemical reactions and through chemical interactions, through chemical quantum mechanical tunnelings, DNA contains genes. So genes, which are very important parts. So genes are built from structures whose behavior is governed at the deepest level by quantum mechanical rules, by quantum mechanics, by the laws of quantum mechanics. And you cannot remove the foundation. You cannot remove the foundation and keep the structure. This is what is important here, is that mathematics has to be the part of these biological sciences in the modern world. Now, if atoms behave probabilistically, if atoms have probabilities, then molecules have probabilities. Then molecules inherit that probabilistic nature. And if molecules inherit it, if molecules inherit the probabilistic nature, then genes cannot be perfectly deterministic. Genes cannot be perfectly deterministic machines. They cannot be completely deterministic robots who can replicate themselves, who can mutate, who can move on. Let's take an example. Take an example of vision. Vision is quantum mechanical. It's a quantum mechanical event. And let's take a biological example. Far from genetic vision, let's try to understand. Now, what's happening? What's happening is that when the light enters your eye, when the light enters my eye, a single photon, what it does basically, it hits the retina. It hits a molecule which you may call as a retinal molecule. Now, what is happening? That photon causes an electron transition in that molecule. That makes a transition of electron from one quantized state to another quantized state. And what happens? That transition changes the shape of the molecule. That transition changes the molecular shape. Now you have a change in the shape of the molecule. Now that change in shape triggers a nerve signal. It triggers a nerve signal. A single quantum event becomes perception. Now, if life depended only on classical laws, if it worked exactly the way classical laws of physics work, this chain would fail. A photon, a retinal molecule, the change in the shape, the change in the geometry, and then a nerve signal. Quantum transitions make it possible. These packeted transitions make it possible. If energy could have been continuously distributed over there, it is impossible to see anything. It is impossible to have that piece of information to the brain. Again, photosynthesis, efficiency, efficacy. In plants, energy transfer during photosynthesis. And what does that mean? Photosynthesis shows what it shows. It shows the evidence of quantum coherence, basically. Because it's not any way close to the classical interpretation of the laws of physics. Energy does not wander randomly and see whoever is coming and hitting. That way, the photosynthesis will take miles to happen. It explores multiple paths at the same point of time and chooses the best path. Though humans are not plants, we are not plants. Our metabolism depends on similar electron transfer. We have the same kind of electron transfer principle. These quantum mechanical coherences are happening in our metabolic system. And that's what leads to that transition. It's those quantum constraints that shape the biological efficiency everywhere, not in plants, as well as in animals, as well as in human beings. Now, the important clarification that I would like to give here, the important argument that I would like to share is that saying life is quantum, it does not mean life is mystical. It's not mystical. And at the same point of time, it does not mean that consciousness collapses the wave function. Even though the consciousness is a result of the collapse of those events which are not allowed. What it means is that it means something simpler. It means something powerful. It means something deep. And what is that? It means life is built. It's built from matter that obeys quantum mechanical laws. Even though we don't understand the whole of the quantum mechanics, and those laws shape what is possible. And not everything is allowed. That's what makes this part of science so beautiful. That everything is not allowed. What is allowed is only what is permitted. What is permitted by the quantization of energy of the electrons. What is permitted by the probability distribution of electrons. what is permitted by the interaction rules that you can have between the molecules, that you can have between the atoms. This is what is allowed. So with this, I hope you like it, and I hope you enjoy it. And let's keep on trying to understand the things. And we cannot understand everything, but whatever we understand, we would like to try to understand to that level. So